All right, so what we're doing here for complex fractions is essentially you're going to see a set of fractions divided by or over another set of fractions. So something like this, where we have a group of fractions on this top part and then just something else in the denominator here. So the way we're going to simplify complex fractions such as these is the trick is just focusing on one section at a time. Like just focus on this numerator part and then try to condense this and simplify this so it's just one fraction. And the way you do that is how we did the last section of notes. It was combining like terms, getting common denominators, and just condensing it into a single fraction. So for something like this, my denominators are just 3 and 4, so I'll multiply this by 3, make sure you distribute, and I'll multiply this by 4 on the right side. So that way we get a common denominator of 12. So when I simplify the top part of this, we will have 3u plus 6 when you distribute that 3. And then we will have denominator 12. And then same on the right side, we just do 2 times 4, also a denominator of 12. Now, since they're both over the same denominator, just like we did before, we will condense it into a single fraction as that common denominator. Just simplify that up a little bit more, so we would have 3u minus 2 over 12. So that's just the numerator part. What we're going to do next is carry over this denominator part, like u plus 2. And once you have a single fraction, divided by essentially another single fraction. So if it doesn't look like a fraction, just remember it can always be written as over 1. So as long as you have one fraction being divided by another single fraction, it's how we handle fractions divided by fractions. We instead change it to the first part of the fraction multiplied by the reciprocal of the bottom part. Now we just do 1 over u plus 2. Now here you would follow any common rules of simplifying when multiplying rational functions and rational equations, where if there was any common factors, you would cross them out. Nothing factors here, nothing crosses out, so we are just going to simply multiply 3u minus 2 times 1. And then the denominator will just have that 12 times u plus 2. You don't need to distribute the denominator. If you don't want to, you can call that 12u plus 24 if you like. The other thing we'll practice doing here later on, we'll also kind of start talking about domain restrictions again, but we'll leave that for a little bit later into the next section of notes. Let's do another example. Let's do one like this. So here again, we have a fraction divided by another fraction. So this top fraction has 2 fractions being added or subtracted. What we want to do is we want to actually subtract them, condense them, so that it turns into a single fraction. And just focus on one part at a time. So what we need to do is we need to multiply this by x squared, top and bottom, and we need to multiply this by a 2, top and bottom, to get common denominators. So we will have the common denominator of 2x squared. I'll multiply x times x squared, giving me x cubed. We are subtracting, x cubed, and then 2 times 2. The denominator part of this, just down here, it's already a single fraction, so there is nothing we need to do with this guy at all. And just like before, once you get one fraction divided by one fraction, what you'll do instead is you'll multiply the reciprocal. So again, we'll take the first fraction, so x cubed minus 4 over 2x squared, and then we'll multiply by the reciprocal of the bottom fraction, x squared over x minus 4. The x cubed minus 4 looks like it may factor like difference of cubes, but 4 is not a cubed number. If it was x cubed minus 8, we could actually factor that further. So nothing crosses reduces with these two factors since that x cubed is there. But here we have an x squared, and that's a factor of x squared, so those can at least cancel out. So my final answer is going to look like x cubed minus 4 on the top, and then 2 times the quantity of x minus 4. And we would leave that as our final result. Let's try one more. Something maybe a little trickier. Let's try this one. So here we have two fractions on the top, and we want to condense that into one fraction. So we will add these by getting common denominators. So in order to do that, this has a factor of m plus 5. This has a factor of m plus 3. So this right one needs to multiply by m plus 3. And this left one needs to be multiplied by m plus 5. Whatever you do in the bottom, you need to do in the top. And then just remember to distribute. So my numerator, to condense that to one fraction, would have 6 times m plus 5. So I'm just going to distribute 6m plus 30. Make sure I pay attention if I'm adding or subtracting. So if I'm adding, we don't have to pay too much attention to the signs. We'll just have a plus 4m plus 12 when we distribute that. And then the common denominator on the top half of this big fraction is the quantity of m plus 5, m plus 3. And you're definitely not going to want to distribute any kind of denominators here. It's going to help you a lot more to keep it factored form. So let's continue simplifying this top half of the fraction because there's some like terms up there. So that would be 10m plus 42 and m plus 5, m plus 3 in the denominator. Now, do the same process for the bottom. We need to get these two fractions on the bottom half to also have a single fraction, so we need common denominators again. This one's just going to be a little bit easier because all we need here on the left is multiply that by a 6, top and bottom, and then we need to multiply this by m plus 3, top and bottom. And we're just going to remember to distribute everything if there's 2 or more terms. So my bottom half will distribute that 6 with the 6m plus 30. Now we are subtracting here, so you do want to pay attention to that sign. Make sure you distribute that minus sign across both terms here. So if I completely distribute m plus 5, m plus 3 out, we'll get m squared plus 3m plus 5m plus 15, which is m squared 8m plus 15. But remember that we are subtracting this product. So what I really have is minus m squared minus 8m minus 15. And then the common denominator is just the 6 and m plus 3. And then just like the top half, you're going to simplify whatever like terms you have. So it looks like I have a negative m squared, a minus 2m, and a plus 30. And over the common denominator. Last step you need to do is that now we have a single fraction on the top, and we have a single fraction on the denominator. We can now do the multiplying the reciprocal. So I'll take the first fraction. And while I'm at it, I see there's a GCF up there, so maybe I'll take out a 2 and have 5m plus 21, just in case there's any common factors to cross reduce. M plus 5, m plus 3. And then I'm going to turn this division into a multiplication, and then I'm just going to do the reciprocal. So now the 6m plus 3 is on the top. And then this is a trinomial. It may factor. So the first thing I'm going to do is pull out that negative and see if I can factor that. So m squared plus 2m minus 30. And then looks like nothing else will factor into this. So just checking in case. So 6 and 5 doesn't work, and 10 and 3 doesn't work. But just in case, making sure if that did factor, we could actually cross-reduce. So now we have negative m squared minus 2m plus 30 on my denominator. So things that can cancel out, looks like just the m plus 3 common factors. And that would be it. So here's how I would write my final answer. First of all, we have these monomial GCFs. They can combine. You can just multiply that and call it 12. I wouldn't bother distributing that into the 5m plus 21. And then my denominator, we just have that m plus 5 left over on the left part, and then this longer one, negative m squared minus 2m plus 30. And that would be my final result. So So if you guys have any questions as you're practicing these and working on these, feel free to shoot me an email. And good luck with everything.